All right, so these are the rules that you're given about the different types of transformations that we can have. So you'll see the different types we have are translations. And what this means is if we have our coordinate plane, and here we have a figure, a translation is that we're just sliding it. So this figure doesn't change its orientation or the way it looks as far as like the way it's facing, up or down, reflecting. All this is just sliding. All right, so we're just moving it and sliding it across. There's no spinning to it, there's nothing else. Then after that, we will learn about reflections. And reflections is like what you think if you look into a mirror and you raise up your right hand. Well, in the reflection of it, looks like it's raising the left. It's the opposite of it. So in a reflection, and we're going to go through all three different kinds of these here and these examples because those ones have different variations to it. I just want to make sure that we can go through. So if we have a reflection, we can have our original image here, a rectangle, and we can reflect it about the y-axis. So it just is here. So it's just a mirror image. It's just flipped over. We can reflect it across the x-axis where it's just flipped over that way. Or we can reflect it across the line of y equals x, which can look something like this. So it's just reflecting about there. So we can have different kinds of reflections and where they're reflected at, and each one of them has their own rule, and we're going to go through each of those individually just down low. But those are the different reflections. It's just like a mirror image that we have. So I'm just going to write mirror image. And you guys should learn all these in grade 8 as well, as it is part of the standards there. Rotation, that is we're turning it. So if I have a figure that looks like this, if I'm rotating it 90 degrees clockwise, well, 90 degrees is going to be where it is now going to be facing this way. That would then be a 90-degree turn clockwise. A 180-degree turn clockwise is going to be where it'll look like this. So it's now turned if you can imagine, this point here is now this point here, which is now this point here. So 180 is a turn halfway around a circle, if you can imagine that. And then the last one, if we then draw the image here, this will be our 270-degree turn clockwise. So you see the point is staying on top every single time that we have. We're just rotating or turning the figure. And usually we're rotating it about a point. And in this case, they're about the origin. So it's like this point here we're using as our means. If you can imagine, has like a dial on it that we're turning it where that is the center that the figure is being turned about. And then dilation. So let me just write here, turning. And dilation, this means it's enlarging or shrinking. So enlarging or shrinking. All right, and we're going to go through examples of reflection and rotation here. And then the way you're going to be assessed on this is your assessment on this topic is going to be on IXL. So there's an assignment for you to do on there. I'm going to go through one of each types of problems that are there. So you can look to see what number I'm going through and help you answer that one if you need it, and then apply that to the other questions as well with these rules in mind. And that's what your assessment's going to look like. So your assessment for this topic is just going to be on IXL because part of the standard is talking about using technology to graph as well. And since you are using IXL to plot points and graph, we're going to use that for this assessment. And then there might be like one or two questions that you will have to plot by hand on a graph paper because I think it's actually easier to do that than using IXL or technology anyway. But that's what our next topic's going to be on, just this, and that's what our next standard's going to be assessing. All right, so I'm going to do these reflections, the different reflections here below. The one thing that you just need to just make sure that you understand is that when we do any kind of transformation, the way that we denote the new figure is we put these apostrophes next to it, but it's actually referred to as prime. So that means that A, and we use the words mapped. So A was mapped onto A prime, B was mapped to B prime, and C was mapped to C prime. So when you see those apostrophes, it's telling us that that's our new image after any of the transformations have occurred. All right, so now for this reflection, I'm going to draw my first figure. Let me just pause this. I'm going to draw the first one for all of them. All right, so for A, we're going to reflect it across the x-axis. So what that means is, I'm going to make this nice and bold here, is here is our x-axis. So we're going to make the mirror image on the other side of that. So we're reflecting it on the other side. And our rule that we follow is that when we're reflecting across the x-axis, The only thing that you're going to notice that changes is the y. The x, because it's a mirror image across the x-axis, it's going to be in the same location for all of our x's. So our x values don't actually change. It's just our y values. And what we do is, because we're reflecting across the x-axis, these numbers are all positive in y, these numbers are all negative. We're just taking the opposite sign of our y when we're reflecting across the x-axis. So a prime, the x doesn't change, but our y becomes negative 2, 7. So this now becomes, 2, negative 7. So then we have 2, and we're going down to negative 7. So there's our a prime. Our b prime, we are now going to just make our y negative, so it's 7, negative 2. So then here's our b prime, so 7, negative 2. It's just flipped across that or x-axis. And then c prime becomes 2, negative 2. So it just flips over here. And now once we plot those points, we're then just going to draw our triangle together. So that is a reflection, a mirror image of our triangle ABC across our x-axis. When we go to do our across the y-axis, so once again, I'm just going to make this nice and thick so we see where we're actually reflecting it. So once again, since we're just reflecting across the y, our y values aren't going to change anything because it's going to end up being almost the same image just on the other side of it. So our y value doesn't change. But since we're jumping across our y-axis, here our numbers are negative for x, and on this side of the y, they're positive. So then when we're reflecting across the y-axis, the opposite variable just needs to change its sign. So a prime now becomes positive 3, 7. So a is going to be positive 3, 7. And I can write a prime there. And b prime is going to be 6 and 7. So now b prime is going to be 4, 5, 6, and 7. And then for c prime, we are then going to have 6 and 1. So it's going to be 6 and 1 here. So you see it's just a mirror image, a reflection flipped over of our original triangle, but just on the other side of that y-axis. So in this case, we're then applying this rule to that one specifically. All right, now this last one, it says across the line y is equal to x. So y is equal to x is a line where we have a slope of 1 and passes through our origin of 0, 0. So this is what our y is equal to x graph looks like. So we're reflecting it across there. So if you think about it, in this case, we're reflecting it across the x-axis and across the y-axis. So then what's happening here is that since we're doing multiple reflections, all we're doing is just changing our x and our y because we're jumping both of them. So if we're jumping from here, we're changing the sign, we're changing the sign again. It's just going to be reflecting it 3, 2, 1. All right, so for this last one, C, we're reflecting it across the line of y is equal to x. So I drew the blue line of y is equal to x. It is our slope of 1, a y-intercept is 0, so that's the line that we're reflecting across. And if you think, we're reflecting it and jumping over this line, so it's going to look something like this now. And here, if we think about our x values and y values are both positive. Here, our x values are negative and our y values are positive. Here, they're both negative. And here, our x value is positive, but our y is negative. Well, when we're cutting across this line of y is equal to x, we're jumping from what's called quadrant 4 to quadrant 2. Because we're not going to, if we're reflecting across this line, it has to go across it. So we're not going to be able to reflect it in either of those two quadrants with the way it's written. So if you notice what's happening here, our x value was negative, our y was positive. Here it's reverse. So when we are reflecting across that or y is equal to x line, we're just switching what our x and y's are because we're jumping across and we're going into the opposite box, which just switches our x and y values. So for this last one, my a prime, well, since a was 6, negative 2, it becomes negative 2, 6. So negative 2, 6. And that's my a prime. B prime is now going to be switched. So it's going to be negative 6, 2. So negative 6, 2. And then my c prime is going to be negative 2, 2. So negative 2, 2. So there's my c prime. There's my b prime. And there's my reflection. So when we are reflecting across that y equals x, we are just going to be switching those. Now, I'm not going to go through, I was going to go through the rotations, but this is the same thing as what we just did here. You just have to just know these rules, and then when we're rotating 90 degrees, 100, 270, that's just what we just have to do, just memorize these rules of how we're applying it to it. For interest of time, I'm just going to stop here with the explanations, and if you need me to go through rotations in particular, we can, but we'll go through as we're going through the next couple of questions as well. All right, so for these questions, it says, and you might be given this in reverse where I give you the scale factor and then you have to draw the new triangle, but this one says rectangle P prime, Q prime, R prime, and S prime is a dilation of rectangle PQRS. So that means we're going from PQRS to P prime, Q prime, R prime, and S prime. So this is what we're going from. Dilation means enlargement or enshrinkment. And we see here's our PQRS, and it's clearly the smaller one. So what we're going to do is just write out what those coordinates are. So let me erase this so we can see a little bit better. So P is -2, 0. Q is 1, 0. R is 1, -2. And S is -2, -2. And now I'm going to look and see, well, what is my prime? So what is P prime? Well, P prime is 10, 0. Q prime is 5 and 0. R prime is 5 and -10. And S prime is -10, -10. So when we're trying to figure this out, all we can do is just say, okay, P prime was -10. So P started out at -2 and it went to -10. So -2 times what gives me -10? So -2 times what number gives me -10? Well, that number would then be 5. So once I figure that out, I can just check to make sure I'm right by just multiplying 5 to every other number. So 0 times 5 is 0. 1 times 5 is 5. 0 times 5 is 0. 1 times 5 is 5. -2 times 5 is -10. -2 times 5 is -10. So they're all. So you see here my dilation factor, scale factor, is by 5. So if we are enlarging it, it will be a number greater than 1. If it's smaller, if it's getting smaller, then we would say like 1/2. So if we started out with this blue figure and we were going this way, well, then our scale factor would have been 1/5 and not 5. So to make things smaller, it's going to be a number between 0 and 1. And to make things larger, it'll be a number greater than 1. So we don't necessarily say it's we're shrinking it by a factor of this. We just say it's a scale factor of 1/2. We don't say it's enlarging it by this. We just say it's a scale factor of 2. Any number greater than 1 is understood it's making it larger, and any number between 0 and 1 is understood it's making it smaller. All right, I didn't say this in the last one, but this is covering these questions 5 through 9, and this is question 5 itself. That last one was question 1. So it says, which image shows a translation? So translation is sliding. So this is just identifying. So since I see that this little line here is on the right-hand side and here it's on the left-hand side, I know that it can't be this because that means it was turned, reflected. Something was happening to it. Here I see that from the small side, the corner here is like the angled corner is below it. And here's my small side and the angled corner is above it. So I know that that had to be, once again, turned or something. The orientation has changed. So it can't just be slide. Here I see that I have the small and I have the corner below it. I can look to see if I wanted to count that they're all moving at the same pace up and over. So this one, B, would be our translation. So when you're asking to identify, you just have to just go through and actually be able to see, okay, is it turning, is it rotating, reflecting, etc. All right, so this one says, what combination of transformation? So once again, this is questions 10 through 13, and this is going to be question 10, I believe. So when we see this here, a reflection is a mirror image. So if this was to be reflected, let's just say around here, it would be a mirror image. So it would actually be closer to where it's like this, because it would have to be the same distance away from this reflection on both sides there. So this is not a reflection. We can see that this here is being turned to there. So that means since it's being turned, it's being rotated. And then, so first it's being rotated. So I'm going to then cross out these reflections. And then from here, we see that the orientation of these two triangles are exactly the same. So it was a slid to there, which then means translation. So this would be a rotation, then a translation. Once again, these ones you just kind of have to just be able to practice and identify what a rotation looks like versus what a reflection looks like, and so on. All right, so this is one when we talk about translation, you need to understand what right means, left means, up, down means. When we say right, we're moving in this direction. What is the only variable in our coordinates of x and y that get changed when we move right? If we're not moving up or down, the y's don't change. So when we move to the right, we are going to add however many we're moving to x. If we move to the left, well, that's moving towards the negative numbers, so then we will subtract 2x. If it says move up, well, up is now only affecting y, and up on y means positive, so we will add to y. And when it says down, well, down once again only affects y, and down on a y-axis is starting to get more negative numbers, so then we will subtract to y. So here the question says we're sliding after translation of 4 units to the right. So what I need to do then is I first need to figure out all my points of my x and y. So r is negative 7, 5. S is 1, negative 2. T is 1, negative 4. And Q is negative 7, negative 5. So if we are just sliding or translating 4 units to the right, I need to add 4 to all my x's. So then my r prime is going to be negative 7 plus 4, which is negative 3. And since we're only moving to the right and not up or down with it as well, then there is nothing changing to my y. If we were doing 2 translations, then you would have to change both your y and your x. Here, it's going to be 1 plus 4, which is now going to be 5. So it's 5, negative 2. For my t prime, it is now going to be 1 plus 4 again. So it's also going to be 5, negative 4. And my q prime is the same one as my r because it started as negative 7, so it'll be negative 3, 5. All right, negative 3, 5. So now we just need to plot them. So r prime is negative 3, 5. So there's my r prime. T prime is 5, negative 4. So here's 5, negative 4. Q prime is negative 3, 5. So I know it's going to line up with here and here. So there's my Q prime. And S prime is going to be 5, negative 2. So there's my S prime. And now I just will draw my lines connecting those. And you see it is just a sliding from that first one to the second one. All right, so this one here, I believe this is number 18. It's a reflection over the x-axis. So you just have to know those rules. And with our rule of reflecting over the x-axis, remember when we're going across here, the only thing that's changing is our y, and y started out as negatives and it has to be positive now. So that means when we're changing our reflection, the x doesn't change, but then we're taking the opposite sign of our y whenever we're reflecting across the x-axis. So once again, we're just going to go ahead and write down our original numbers. So t was 1, negative 4. S was 5, negative 4. R was 5, negative 8. And Q was negative 4, negative 8. And now to make these a reflection across our x-axis, we're just changing our y value to the opposite sign. So T prime becomes 1, 4. S prime becomes 5, 4. R prime becomes 5, 8. And Q prime becomes negative 4, 8. So now we're just going to go ahead and plot those points. So negative 4, 8 for Q. So let's list that as Q prime. R prime is 5, 8. So here's 5, 8. So there's R prime. S prime is 5, 4. So there's S prime. And T prime is going to be 1, 4. Now we just draw our line connecting them. And there's our reflection image across that x-axis. All right, so for this one, we're rotating around the origin. We're only going to worry about the ones around the origin. If there's any one I give you beyond that, it will just be considered exceeding. And remember, we have these rules you just have to remember. So our rule for rotating 180 degrees around our origin is that our x and y then turns into a negative x and negative y. And just think about that. We're rotating it about here. So we're imagining that we're changing this and we're rotating 180 degrees as a semicircle. So we're rotating it here. So our X and Y values are now jumping from quadrant 1, which we talked about in that other part of the video, positive, positive, to quadrant 3, which is negative, negative. And since we're not reflecting it, we're not changing like X and Y moving into like they're both still going to be at the same height, because this one here, when we rotate it, it's still going to be our Y value. So we're not changing our X and Y's like we do for the 90 degrees or for the 270. They stay in the exact same X and Y, but now we're just changing both of their signs, because when we do a 180 degree turn, we will be going from one quadrant to the opposite. And in those cases, both signs are changing for our X and our Y's. So what we do is what we did on the other one. We just write down our original coordinates. So H is 3, 7. G is 9, 5. And F is 9, 3. And then to map these with a rotation of 180 degrees around the origin, our H prime, we just change them both of the signs, become -3, -7. Our G prime becomes -9, -5. And our F prime becomes -9, -3. And now we're just going to go ahead and plot the new points. So H is -3, -7. So there's our H prime. Our G is -9, -5. So -9, -5. That's our G prime. And our F prime is -9, -3. So -9, -3. That's our F prime. And now we just draw our line connecting those. And you can see that this is a rotation. So this, as it's being rotated, here you can imagine, like, if we can imagine drawing, like, it'll still be like this. So our H is still going to be on that other end. If it were to be the opposite way, it would be a reflection of it. So that's being rotated. All right. So that's it for this video. And this IXL is what we're going to do the next few days, because this is essentially what your assessment is going to be.